All right, today we are going to start talking about the tangent ratio for section 10.4, but first, let's get through these warm-ups. So we are just going to find any missing sides that are labeled. So for 1 and 2, we just have one thing to find. On number 3, we need to find both missing sides. Now again, if you don't like the fact that they used an X, I would maybe just cross it out and put a question mark on that side instead to show that that's the side that they want us to find. So if you would prefer to just use a question mark instead of the letter X because we use that letter when we set these problems up, that's fine. And number 3, we would have 2 question marks. All right, when we label 30, 60, 90 triangles, the side across from the 30 we always called X. So across from the 30 is X. They did not ask for the side across from 60, but what do we usually label it as? No. X radical 3. The X radical 2 is only 45, 45, 90 triangles. Okay, and the side across from the 90 is 2X. That's the side that they want us to find. So in order to find it, we need to know what X is. What does X equal? 2 times 5 is 10. So 10 is the answer to number 1. Because they did not ask for the side across from the 60, I'm not going to fill it in. If you did, that's fine. All right, on number 2, the side across from the 30, we usually label with X. That's the side we're looking for. The side across from the 60, we label X radical 3. So now we've set up an equation for ourselves. 18 equals X radical 3. We need to solve for X. That's what we're trying to find. How do we do it? Divide by radical 3. That will get the X to be alone. So we have X equals 18 divided by radical 3. Can we leave it like that? No. What needs to change? The denominator. We cannot have a radical in the denominator. So we're going to multiply the top and the bottom by that radical 3. For now, in my numerator, I just have 18 radical 3. In my denominator, radical 3 times radical 3 equals 3. Can that fraction simplify?
Yeah.
Yes, 18 over 3 is 6. Does the radical 3 change? No. So that would be our answer for number 2. 6 radical 3. Questions about number 2? Okay, again, they did not ask us for the side across from the 90, but we could find it by taking X times, what do we multiply X by to find the side across from 90? By 2, 2X. So 2 times X gives us the side across from 90. So yes, it would be the 2 times 6, so 12 radical 3. They didn't ask for it, so we won't worry about filling it in. On number 3, the side across from the 30, we should label with X. The side across from the 60. Just okay, X radical 3. And the side across from the 90 is 2X. Now on this one, they did want us to find both missing sides, so we just have to plug X in. Instead of X radical 3, this would become 7 radical 3. And 2 times x is equal to 14. 2 times 7 is 14. All right, so our objective is to use the tangent ratio. Let's first talk about trigonometric ratios and what they are. A trigonometric ratio is the ratio of the lengths of 2 sides of a right triangle. There are 3 trig ratios, or trigonometric. Usually we just shorten it to trig. There are 3 trig ratios. That's on your notes. It's not on the slide. Today we are going to focus on tangent, which we usually just call tan. We write it as T-A-N, all lowercase. The tangent ratio, which you can put in that box, is equal to opposite over adjacent.
Opposite over what?
Adjacent. It's on the board. Ooh, too far.
What goes?
Okay, I would make sure this diagram gets added to your notes. A right triangle with 2 angles labeled, one capital A, the other capital B. I would also label the sides. Usually in geometry and trig classes, the side across from angle A, which angles we use capital letters, the side across from angle A we label with a lowercase a, and the side across from angle B we label with a lowercase b. Okay. We have to be specific about our capital and lowercase letters. When we write this, if we are talking about the tangent of angle A, we would write TAN, all lowercase, with a capital A next to it. That refers to the tangent of angle A. It's equal to a ratio, or we usually write it as a fraction. The side opposite that angle, so what did we label the side opposite angle A? Lowercase a, over the side adjacent to angle A. So the side adjacent to means right next to, lowercase b. Usually we'll have numbers for little a and little b. Okay, but this is how these problems will be set up. Now normally when we see right triangles, we have a side labeled A, a side labeled B. What do we usually label the other side in a right triangle? C. Okay, we usually label it C. You can do that here. What's important to notice is that when we are setting up tangent, what's another name for side C? What do we call that? Starts with an H. The hypotenuse. When we're using the tangent ratio, we are never using the hypotenuse. So put a little cross out letter C, cross out that side. If you're using tangent, you are not going to use the hypotenuse. Are we all okay with that? Okay, so then let's also talk about angle B. Tangent of B. What side is opposite angle B? Little b, lowercase b. And what side is adjacent to angle B? Little a. Notice that they did not label the last angle. They did not put a name by the 90-degree angle. What side is opposite the 90-degree angle? The hypotenuse. And we are not going to use the hypotenuse. So in a right triangle, we're only ever going to talk about the tangent of the other two angles, the non-right angles. For our first set of examples, we are going to find the tangent of angle A, then find the degree of angle A to the nearest tenth of a degree. In order to find the measure of the angle, that second part of the directions, you are going to need a scientific calculator. If you do not have one with you today, it's fine. I would recommend that we'll look off of a neighbor, someone nearby, so that we can see how this works. Okay, but for now, just get them labeled and see if you can start setting up the tangent of angle A. We'll get to the calculator part in a minute. Okay, we're going to start with number 1. I'm going to cover up number 2 and 3 for just a minute so I've got some room to show my work. I'll bring them back in a minute if you didn't get those down yet. The first thing we are asked to do is find the tangent of angle A. So T-A-N capital A is how we would label that. Tangent is opposite over adjacent. Good, 6 over 8. Can we simplify that? Yes, what would it simplify to? 3/4. So the tangent of A is equal to 3/4. Yes, I would expect you to simplify it if you can. Are we all okay with that? Opposite over adjacent. They didn't even label the hypotenuse because we're not using it. Sometimes they will label the hypotenuse on these problems to see if you really know what you're doing. Okay, the next step is to find the measure of angle A to the nearest tenth of a degree. Now, you know I don't usually like rounding. There's no way around it with some of these problems involving the trig ratios. So we'll just have to do the best we can. What this means is that we are trying to get A by itself, capital A. In order to do that, this is how it works. We are going to have to undo tangent. So right now we have tangent A equals 3/4. To undo tangent, tangent is considered a function, so we have to use inverse tangent, or tan to the -1. It's called inverse tangent. But we know from algebra 1 that if we do something to one side of an equation, we have to do it to the other side. Yes. Tangent, and it's like an exponent of -1. We call it inverse tangent. Now on the left side, inverse tangent and tangent, those cancel each other out. Kind of like a plus and a minus, or a square and a square root. So all we're left with is capital A. Here is where our calculators come into play. Our calculators are able to take inverse tangent of 3/4. Not tangent of 3/4, but inverse tangent. So usually if you find the tangent button, the inverse tangent is the secondary function above it. So for most calculators, we press second tan on our calculator and then type in 3/4, 3 fraction 4, or 3 divided by 4. All right, so we should have gotten 36.9 degrees rounded to the nearest tenth. So angle A measures 36.9 degrees. Don't forget your little degree symbol. Yes, it's your units. So this question had 2 parts, so we should have 2 parts to our answer. The question has 2 parts, so does our answer. The first part was to find the tangent of A. Just set up that ratio. Tan A equals 6 over 8, which reduces to 3 over 4. The second part of it was to find the measure of angle A. So we used inverse tangent of that trig ratio, 3/4, in our calculator to get the answer. We rounded to the nearest tenth because that's what the directions said to do. Questions about anything we did for number 1? All right, on number 2, we have the same type of problem. We have to find the tangent of A, then we will find the measure of angle A. So tan capital A equals, Martez?
Do you always have to find tan A?
That's what the direction said to do. So if it says find the tangent of angle A, that's tan A.
So if we do find the tangent of angle A, not angle B, then the opposite, right?
It would be the reciprocal, yes. What is it, Keon? So we start at A, we go opposite A is 12, and then adjacent is 5. Opposite goes on top, opposite over adjacent. All right, then in order to find the measure of angle A, we have to use the inverse tangent on both sides. So the measure of angle A is going to equal inverse tangent of 12 over 5. That's what we're going to put in our calculator in order to find the measure of angle A. Jordan? Sure. 67.3 degrees. Does anybody agree? Would it round up to 4? What comes after the 3?
8.
Okay, so it would go up to 4. Are we all okay with our rounding? Are we all okay with using our calculator to find these? All right, let's talk about number 3. First thing we need is to find the tangent of A. Who can help me out with the tangent of A? Mariah? 40 over 9. Thank you, Mariah. 40 is opposite A, 9 is adjacent to A. We do not ever use the hypotenuse when we're doing tangent. Later this week, we'll talk about a couple other trig functions where we will use the hypotenuse. Okay, but for today, we are not using it. The other thing we need to do is calculate angle A's measure. So in order to do that, angle A is going to equal the inverse tangent of that ratio we just found, 40 over 9. What is it, Mariah? So to the nearest tenth, 77.3 degrees.
Yeah.
Anybody else agree? Okay, so these would be our 2 answers for number 3. So now our directions. Now our directions are to use examples 1 through 3 and find the degree of angle B to the nearest tenth. Now there are 2 ways that we can do that. One would be to set up our tangent ratio for angle B and solve it just like we were doing for angle A on 1 through 3. Or if we just sketch that triangle, it was a right triangle, right? It was angle A at the top or the bottom?
Top.
Angle A was up at the top. And what was angle A's measure on example 1?
Wait, no, this was on the bottom.
Oh, A was on the bottom? Okay, and B was on the top. What was the measure of angle A that we found?
8.
For example 1. Good, 36.9 degrees. So can anyone think of another way that we could find the measure of angle B other than using our trig ratios all over again?
Yes, I can.
Keon.
So you take the 36.9 and just round it to 40 plus the 90-degree angle, and you'll get like 130, and then you take the 130 minus from 180 to get 50.
Okay, I almost like everything you said. Now, I like the subtracting from 180 part. The part I don't like is the rounding, because our directions say find it to the nearest tenth. If this is already to the nearest tenth, then that's going to help us get this answer to the nearest tenth. So you can either use your trig ratios, or if we have a triangle and we know two of the angles, we can take 180 minus the angles that we know, and then we can get an answer.
What's in it?
So did anybody take 180 minus 90 minus 36.9?
No.
Do we agree with 53.1? Okay, so that would be our answer. Angle B, or you could just put B, is equal to 53.1 degrees. If you want, you can use your trig ratios and use your inverse tangent over again, but you do not have to. That would be our answer for number 4. Anybody get the measure of angle B from example 2? Keon? Keon, go ahead. 22.6? 23.6? Are we all okay with 22.6 degrees?
Yes, ma'am.
We shouldn't have to be rounding on these ones because we already rounded when we found A. These ones, our answer should just be to the nearest tenth when we subtract. Did anybody find angle B from number 3? Jordan. 12.7 degrees. Anybody else get that? Wonderful. We have one little question at the bottom of the slide. What do you notice about angles A and B? Jordan, what do you notice? Perfect. When you add them together, they equal 90. The sum of those two angles should equal 90. So you could just say A plus B equals 90. That should happen every time. All right, so now we are going to work on finding a leg length. So far, we've always been told the sides of a triangle. So it says this time we have to work a little differently. We are given the angle measure and one side, but need to find another side. Can we do this? Yes. Just set up the same cross product and solve. So it'll be the same type of equation. It's just going to be a little bit different in our calculation and how we use our calculator. On number 7, we are going to start off by setting this up the same way. It's just that we know something different this time. So when I'm talking about tangent, I always put tangent of an angle. Okay, this time I know what the angle's measure is. What is it? 42. So I'm going to put tangent 42 degrees instead of tangent A or tangent B, because I actually know what the angle is. If you don't put the parentheses, it's fine. You don't have to have those parentheses there. So we're talking about that angle of 42 degrees. When we're talking about that angle that's labeled 42 degrees, if we're talking about tangent, we're still talking about opposite over adjacent. What is the side opposite that angle? 12 is opposite or across from it. And what side is adjacent? x. We're still not using the hypotenuse. Now, if I wanted the left side to be written as a fraction, I could put it over what? Anytime you want to turn something into a fraction, you put it over a 1. So this is why your notes mentioned a cross product. If we're trying to solve for x, we need to set this up as a proportion, so fractions on both sides, so that we can cross multiply and then solve. Now, if it makes you feel better, you can go ahead and calculate the tangent of 42 degrees right away in your calculator. This time, we would not use inverse. It's just plain tangent. So if it would make you feel better to get rid of tangent right now, type in your calculator tan 42 equals.
88.6.
What after the two?
I got 0.9.
Okay, your calculator still should be set into degrees. So at this point, if you want to replace the tangent 42 degrees with 0.900, okay, we need a few decimal places, but they end up being zeros on this one. That's fine. Don't round this to the 10th yet. Don't round to the 10th until the very end. Keep a couple decimal places for now. When we cross multiply, I'm going to be multiplying 0.9 times x. We're just cross multiplying. So 0.9 x equals 12 times 1, which is 12. To get x by itself, what am I going to do? Divide by 0.9. Now is when we would officially round to the nearest tenth. X equals anybody take 12 divided by 0.9? 13.3. Okay. So that's what we're looking for. The variable was that unknown side. We should get 13.3. We are going to pick up with the last few examples tomorrow.